Okay, so in the module we solved the system of three equations: x plus 2y minus 6z equals negative 17, 2x minus 5y plus c equals 28, negative 3x plus 4y plus 2z equals negative 21. Now we started it in the module by solving for x, but I wanted to do it a different way just to show it doesn't matter what variable to solve for. Also to kind of reinforce or rework the problem just to get a better handle on it. Okay, so what I'm going to do instead is I'm going to pick another variable to solve for. First, to eliminate, let's eliminate z. Okay, so what I'm going to do is I'm going to pick the last two equations and eliminate z from those. Okay, so let's go ahead and do that. So I think the easiest way to do that here would be, I'm going to use the elimination method for those. I'm going to multiply the first equation by negative 2. Okay, so when I do that, we're going to get, if you multiply everything by negative 2, we get negative 4x plus 10y minus 2z going to equal negative 56. Okay, we don't need to multiply anything to the second equation. So you're going to see we got exactly what we need in order to cancel out z. Alright, 21. So now, using the elimination method, we add the two equations together. Negative 4x plus negative 3x is our negative 7x. Plus, when we add the y's together, we get 14y. And we notice the z's will cancel because negative 2z plus 2z equals 0z, which is 0, so the z will be gone. And that's going to equal negative 56 plus negative 21, negative 77. Okay? So, we eliminated z from one pair of equations, now we need to pick another pair. Alright? So, I'm going to pick the first and the second equation, and we're going to try to eliminate z. Alright? Now the easiest way to do it this time, I'm going to multiply the second equation by 6. Okay? That should get us to where we need to be. Alright, so we'll leave the first equation alone. And we're going to multiply everything in the second equation by 6. So we're going to get 12x minus 30y plus 6c is going to equal, and 28 times 6 will come out to 168. Okay. And again, we're going to add these two equations together. When we add the x terms, we get 13x. When we add the y terms, we get negative 28y, so it's going to be 13x minus 28y. And when we do negative 6z plus 6z, again, they cancel each other out, so that's good. And then we add the numbers, negative 17, oops, excuse me, that's supposed to be negative 17, sorry about that. So negative 17 plus 168 is going to give us 151. Okay? So now we're down to, we have a system of two equations with two unknowns. Alright, so if you remember from the first pair we ended up with negative 7x plus 14y equals negative 77. And from the second equation, 13x minus 28y equals 151. Alright, so I'm going to use the elimination method again. Alright, and this time the easiest way, it looks like we're just going to eliminate y. And it doesn't matter which one, but just it looks like the most efficient way will be to eliminate y. And what I'm going to do is I'm going to multiply the first equation by 2. That should achieve that. Okay, so when I multiply everything in the first equation by 2, I get negative 14x plus 28y equals negative 154. Alright, not going to need to do anything to the second equation. We're going to keep that the same, 13x minus 28y. It's going to equal 151. Alright. And then we're going to add these equations together. Negative 14x plus 13x is going to give us negative 1x or negative x. The y's will cancel because 28y and negative 28y will cancel each other out. This is going to equal negative 154 plus 151. This is a negative 3. Okay. Since negative x equals negative 3, and if you want, you can divide both sides by negative 1. but this should give us that x equals 3. Okay, so we got one of our unknowns. Alright, let's go back and find another one of our unknowns, and the way we do that is we go back to the equations, we go back to our system of 2 equations, 2 unknowns. When we got to that part, we pick one of those to plug into. Okay, so I'm going to plug into, and again, doesn't matter which one, I'm going to plug into the second equation. So we're going to do 13x minus 28y equal 151. Alright, so we know that x is 3, so it's going to be 13 times 3 minus 28y. And it's going to equal 151. Okay. Now we just do the math from here. We know that 13 times 3 is 39. Okay. And now we're going to subtract 39 from both sides. Okay. So now negative 28y is going to equal 112. And then we finish this off by dividing by negative 28. Which tells us that y is going to equal negative 4. Okay, so we're looking good. Now we have 2 of the unknowns. Now we need to get a third one. And for that, we're going to go to any one of the 3 original equations in our system of 3 equations and 3 unknowns. We pick any one of those to plug into. I'm just going to pick the first one. So we got x plus 2y minus 6z equals negative 17. Like I said, it doesn't matter which one of the original 3 you pick. I'm just picking the first one. And let's start replacing our values. So we know that x is 3 plus 2 times, we know that y is negative 4 minus 6z equals negative 17. So from here we're just going to do the math and try to solve for z. So we're going to get 3. 2 times negative 4 is negative 8. Okay. 3 minus 8 is going to give us negative 5. Okay. And the next step, we know from solving the linear equation, we're going to add 5. Negative 6z going to give us a negative 12. Okay. And then our last step to finish this off is we're going to divide both sides by negative 6. And that gives us our final unknown. We know that z is going to equal positive 2. Okay? Which is the same answer we got last time, just went about it a different way. Okay? So I just wanted to show you that no matter which variable you solve for, it's still going to come out the same. And as a matter of fact, let's go ahead and express our solution as an ordered pair with 3 variables. We're going to have x, then y, then z. Okay? So we know that x is going to be 3, y is negative 4, z is 2. Okay? So many ways to go about doing this. But any way you go about doing it, it's going to give you the same answer. Okay?